Method 2 for calculating these problems would be to use your calculator. My personal opinion is that unless you do this a lot and you get really familiar with exactly how to type things in, it's not going to be as easy, I think, as just remembering how to do things using the z-score table. The other thing that I don't particularly love about this option is that you can't use exact numbers, and I'll show you what I mean when we actually do the problem. And so your answers aren't going to be exactly the same as they would be if you use the z-score table. So I'm going to show you what you need to type into your calculator. We'll do a couple examples. So for the calculator, this is the function that you need. It's called normal CDF. The way that you get there on your calculator, you press second and then the button that says vars, and you're going to choose option number 2. And then the things you need to be typing in this first little section, you need to put a lower bound. The second one is an upper bound. And then in this third section, you need your mean, and then in the last one, you need your standard deviation. Now, the upper bounds and lower bounds are a little bit tricky because really your upper bounds and lower bounds are usually going to be something like negative infinity or positive infinity, but you can't type that into your calculator. So if you just use a really big number, like for example, using negative 1,000 as your lower bound or using positive 1,000 as your upper bound, that will be fine to get you a pretty good answer. So let me make a note of that here. So you're going to use negative 1,000 or positive 1,000. If you need an upper bound or a lower bound, that really would be infinity. So you're going to use those instead of positive or negative infinity. All right, so for part A, and this is the same question, by the way, as the previous slide. For part A, we're looking for the percent of baseball players who are shorter than 72 inches. So what I'm going to do is go through each of these questions and write down what you should type in your calculator and the answer, and then I'll do one example. You'll see a video on the right, so you can actually see me putting it into the calculator. So for part A, you're going to type in you're going to get the normal CDF command, and then here's what you're going to type in. We're looking for everybody shorter than 72 inches, so that's 72 and everything underneath. So our lower bound is going to be negative infinity. So instead of negative infinity, we'll put in negative 1,000. The upper bound is 72, that's the cutoff. And then we need to put in the mean and standard deviation, which were given to us. So mean is 73.5, standard deviation is 2.25. So that you're going to put into your calculator. You're going to press enter, and your answer should come out to be 0.2525. And again, this is a decimal, so that would mean that our answer is 25.25%. Now, if you referred back to the other screen, the answer from part A, when we did this by hand, was 25.14%. So they're pretty close, but again, not exact. For part B, we're looking for the percent of baseball players who are taller than 76 inches. So this is kind of nice on the calculator because instead of having to figure out the percent less than 76 inches and then subtract it from 100, our calculator will take us straight to the answer. So you're going to put in the normal CDF command. This time your lower bound is 76 because we want everything to the right of 76, and our upper bound will be 1,000, and then the mean and standard deviation will be the same. And when you plug that into your calculator, you get 0.1333, and that is equivalent to 13.33%. So that would be your answer. And just as a reminder again, the answer we got on the previous slide was 13.35%. So very close, but not exactly the same. And then finally, for part C, we're going to use the normal CDF command. This time our lower bound is 70, our upper bound is 74, and the mean and standard deviation are the same. And when you put this all into your calculator, you get 52.80, which translates as 52.8%. And then just as a reminder, we got 52.77% when we did this by hand. To do these problems using your calculator, it's really important that you need to know what you're typing in. But once you know that, you're going to press second and then this button that says VARS. And you're going to choose option number 2 that says normal CDF. Do not use normal PDF, you'll get the wrong answer, so it is very important that you use option 2. And then it's going to ask you to plug in your lower bounds, upper bounds. The third thing down, it's a Greek letter called mu, and it stands for mean. And then the fourth thing down is sigma, and we're using S for standard deviation, but that's what those things mean. So we're going to type these things in. For part A, our lower bound was negative 1,000. What they have right here is basically negative 1 times 10 to the 99th power. So this is like scientific notation for a really, really tiny number. I'm going to type in negative 1,000 so that you get the same answers that you see that I wrote when you watch the first part of the screen, the office mix. So I typed in my lower bound. I'm going to press enter. My upper bound is 72. Press enter. The mean is 73.5. Enter. And the standard deviation is 2.25. And then you hit enter twice, actually. And then it puts this up on the screen. And this is how I actually wrote it out in the notes to the left. So if you're wondering why it looked different than it did before, this is why. So then you press enter one more time. So enter 3 times total. And this is the big long decimal that it gave you. I rounded it to 4 decimal places, so that's why I said it was 0.2525. So that was the first one. I'll do parts B and C. You can stop watching if you feel like you understand. So I'm going to go to second VARS, down to option 2. This time my lower bound is 76. My upper bound, I'm going to put in positive 1,000. And then my standard deviation and mean are the same, so I can just basically keep hitting enter until it gives me my answer. And again, I rounded this to 0.1333 because the 6 would round the 2 up to a 3. So that's where I got part B's answer. And then lastly, second VARS, option 2. And rather than using the arrows, you could actually just press the number 2 and it would take you to the same thing. My lower bound was 70, upper bound is 74. Mean and standard deviation are the same, so you just keep hitting enter until you get your percent. So 0.5280 was our answer, and then we converted that into a percent.